Okay, so today we're going to look at graphing sequences. So a linear sequence, like we already know, it is basically going up. The first difference is the same, so it's going to be a line when we actually graph it. It's just going to be a straight line. So here is a linear pattern. So it's 1, 4, 7, 10, 13. So the first difference is 3 between all these patterns. Okay, so term 1 is equal to 1, term 2 is equal to 4, term 3 is equal to 7. Right, so they can also be written as ordered pairs as follows. So T1, 1, T2, 4, T3, 7, T4, 10. Okay. When I plot that, my terms are going to be along the bottom and my values are going to be up along my vertical axis. Okay, so my y-axis. Okay, so term 1 is 1, so I go to term 1 and I plot 1. Right, term 2 is 4, I go to term 2 and I plot 4. Term 3 is 7, so I go to term 3 and I plot 7. Term 4, I go to term 4 and I plot 10. Okay, so your terms are always along your x-axis. So when the terms and its values are plotted, the plots joined, the result is a straight line. Okay, so a linear pattern is always going to give you a straight line, like something like this. Okay, from algebra we should already know what a quadratic should look like when it's graphed, because we have already done these in functions. Okay, so here's a quadratic sequence. Okay, so 3, 4, 6, 9, 13. So for it to be a quadratic sequence, the second difference has to be the same. So I have T1, term 1 is 3, term 2 is 4, term 3 is 6, term 4 is 9, term 5 is 13. Okay, terms always go along my x-axis. So the first one here, I have term 1, 3, so I go to term 1 and I plot 3. Term 2, 4, so I go to term 2 and I plot 4. Term 3, 6, so I go to term 3 and I plot 6, and so on. Okay, so when the points are joined, the results curve forming a quadratic graph. So a quadratic graph is going to be kind of like a little curve. Okay, so a quadratic graph can take one of two shapes shown on the right. Okay, so if the x squared would be positive, for example, we'd know it would be a happy graph. But if the x squared was negative, it would be a sad graph. Okay, so happy face, sad face. The next type of pattern that we have is an exponential sequence. Okay, so here is a special type of sequence formed by powers of 2. Okay, so we know exponential. Okay, so if our first difference is the same, it's a linear pattern. If our second difference is the same, it's quadratic pattern. It is exponential if it's like doubling, tripling, or quadrupling. Okay, so here I'm actually going up in the power 2. Okay, so it's going to be doubling. Okay, so 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8, 2 to the power 4 is 16, and 2 to the power 5 is 32. Okay, so the values of the terms increase very quickly in an exponential sequence. Okay, so if I was also to do for 3 to the power of n, okay, so this will be tripling. Okay, so 3 to the power 1 would be 3, 3 squared is 9, 3 to the power 3 is 27, 3 to the power 4 is 81, and 3 to the power 5 is 243. Okay, so when the sequence 2, 4, 8, 16 is plotted on the graph, it can be seen that it is a curve that rises very steeply. And you would think of this kind of looks like a Nike tick or something like that. It literally goes so rapid. Okay, and I've plotted the sequence here. So it's like a curve. It's more steeper than a quadratic pattern. What I have here then is an example. Okay, so here are the fare structures of two taxi companies. Okay, so company A has a fixed charge of €4 plus €2 per kilometre, and company B has no fixed charge but charges $2.50 per kilometre travelled. And I am asked here to draw a graph to represent these two companies' charges and to put the charges on the x-axis and the distances on the y-axis. Use your graph to find how much company A charges for a journey of 10 kilometres and how far you could travel with a company B for €16 and the distance for which both companies charge the same amount. Okay, so I'm going to do the first part of this question. Okay, so company A, I was told that they charge, okay, and then the final thing is the difference in the charges when the distance is 4 kilometres. Right, so company A, I was basically told that they they have a fixed charge of €4 when you booked them originally, and then they charge €2 for every kilometre you travel after that. Okay, so what I did is I just did a little table, okay, so that I'd be able to actually plot it. Okay, right, so they've travelled nothing, company A, they're still going to be cost €4. When they travel 1 kilometre, okay, they go up €2 for every kilometre, so 4 plus 2 gives me 6. When they travel 2 kilometres, they're going to add another €2 for each kilometre, so 6 plus 2 gives me 8. Okay, when they travel 3 kilometres, I still have to add another €2 on, so that's €10. And then I go off and plot these, okay. So I plot this one here. So the first point would be 0,4. Okay, so I go in the door, up the stairs, that's it. Okay, next one is 1,6. Okay, so I go in the door to 1 and up the stairs to 6. Next one is 2,8. So I go in the door to 2 and up to 8. My next one is 3,10. So I go in the door to 3 and up to 10, and so on. Okay, you didn't actually need to draw as many points in a table, because we know it's a linear pattern, so it's just going to take the form of a straight line. Okay, but I just drew a few extra ones so that I would be able to show you here. Okay, for company B, we're told that when they travel nothing, they don't have fixed charge, so they cost nothing. Okay, but for each kilometre that they travel, they have to do 2.5, that they get charged €2.50. Okay, so for 1 kilometre costs them €2.50, 2 kilometres cost them €5, 3 kilometres cost them €7.50, 4 kilometres cost them €10, and so on. Okay, and that's a linear pattern as well. I didn't need to do as many in my table as what I did, so I go off and plot this. Okay, so my first point is 0, 0, so I go down here. Okay, my next one is 1, 2.5. Okay, so it's 1, 2.5 here. Okay, next one is 2, 5, so I go 2, 5. My next one is 3, 7.5, so I go in the door to 3 and up the stairs to 7.5, and I plot that. Okay, so my straight line. My first question, okay, so it asks me, the original one, it asks me to find how much company A charges for a journey of 10 kilometres. Okay, so we need to find out how much does company A charge for a journey of 10 kilometres. Okay, so kilometres are along the bottom, and I have company A in blue. Okay, so I need to go, okay, to company A along the bottom here, 10 kilometres, and I draw a little line up here until I hit my blue graph, and I go over, and I see here that they would actually be charged €24 if they want to travel 10 kilometres. The next part of my question then, it asks me how far you could travel with company B for €16. Okay, so company B is plotted in green. Okay, and for €16 the cost is along this way. Okay, so I need to go to €16 and I need to cut all the way along until I hit my green graph. Okay, and I go down once I hit my green, and I get roughly about 6.5, let's say. Okay, so that's how far they can charge a company B for €16. They can travel 6.5 kilometres. Then I'm asked to find out when are they actually equal to one another. How far would you be able to travel when they're both the same? Okay, so they're both actually the same at 8. That's where they cross over at this particular point here. 8 kilometres. Okay, and we can even see from my graph here. Okay, my table that I made out. So at 8 kilometres cost them €20, and here for 8 kilometres it also costs them €20, and that's where they're actually equaling to one another at that particular point there. And then the final question, it asks me the difference in charges when the distance is 4 kilometres. Okay, so I can even read this from my table. Okay, or I could read it from here. I could go, okay, so what did they charge when they're at 4 kilometres? Go up this way, and what does the other company charge when they're at 4 kilometres? But what I've seen here is that they charge €12 for 4 kilometres, and here they charge €10 for 4 kilometres. Okay, so the difference in that is just going to be €2, and that's that question fully completed. If you were asked to get the slope, remember to get the slope, I need to do my rise over my run. So some of the questions do bring in your slope, okay, and that's your rate of change. Okay, so basically for every kilometre that would increase here, there would be an extra €2.